This lesson, we are looking into the last bit of chapter 7, which is about static rigid bodies, 7.4. Now, if you remember in the beginning of chapter 7, I did mention about 7.4 is a standalone chapter, I would say, compared to the previous. We're still working with forces. However, we're not working on particles anymore. So 7.1 all the way 7.6, apart from 7.4, is about particles. So before we're working on the bodies, before working on the 7.4 rigid bodies in today's lesson, just do a quick recap of what we've learned before. Now, in 7.6, which I used the last bit to talk about because that should be something that you have the freshest memory on, is about pulleys, right? So on the pulley, on the inclined plane, this particle A and particle B. On particle A, because the inclined plane, we have a 2g cos 30 and 2g sin 30, and reaction because of pulley of a string, the tension pointing towards the pulley, okay? And then what we did was we will have to resolve any forces not on the axis. These all forces are on there, so we didn't resolve any forces. But if we have to, we do have to, right? And then we sometimes have to include friction, like the previous example number 1 in 7.6. We include friction in here because it's going up, friction is opposite against it. And then you can draw a force diagram, and then using F equals ma in x and F equals ma in y for both particles, you will have an simultaneous equation to solve, etc. And that's how you usually do it. Right, so that's particles, inclined plane. Now, today's lesson, we are moving on to rigid bodies. So rigid bodies is something you have done in moments, which is about a seesaw, about a plank, about a rod, etc. If you remember from chapter 4, there are two things you have to do. One is upward force equal downward force. And then the other one is take moments at a point. That's exactly what you're going to do. But obviously, there are more forces to be calculated, and there are more things to consider. So you can imagine, you can consider this chapter, this 7.4 is an advanced version of chapter 4 on the whole. It's like chapter 4B. Anyway, so for rigid body, not particle, body means a rod. So you might want to write this down. A rod, a ladder. You will see later in this example, you see a lot of similar things. So a rod, a ladder, okay, or something like a plank, something like this. These are called bodies, right? It could be human bodies as well, but let's not go into that field. We're talking about mechanics in here. Just a rod. It looks like ladder. I don't mean to be. Anyway, ladder is a ladder in static equilibrium. So first of all, resultant force in both directions is 0. So upward force equal downward force. Left equals right. That's the very first step we're going to do. Up equals down, left equals right. It's not going to be simple, but here's the concept. Up equals down, left equals right. Next step is to make resultant moment equal 0 Newton meters. So to do resultant moment, again, you will have to actually ignore all of this. Take moment at a point. So actually these three steps. Yeah, sorry, these three steps, that's correct. Step 1, step 2 equation, vertical forces equal, upward force equal downward force, and then horizontal force equal, left equals right. Then you've got to take moments at a point, choose wisely. We talked about that in chapter 4. Determine direction and work out the moment of each force, and then sum of clockwise moments equals anti-clockwise moments. Moments is an abbreviation for moments. Unofficially, that's my definition of moments. They have their moments, right? So these are 3 steps: 1, 2, and 3. Now, note this is not inclined plane. I know you're quite used to doing inclined plane of all this stuff, but that's not the same, right? So let's have a go. So in this chapter, there usually be 3 kind of scenarios. We're going through scenario number 1, which is a rod on a peg. When you do your homework, you will usually encounter one of these 3 examples. Even exam question is always one of these 3. The latter one, example number 2, will be more prevalent than the other ones, 1 and 3, but sometimes you see all of them. So, not all of them, sorry, sometimes you see the other 1 or 3. A uniform rod, so we know what uniform means. Uniform means center of mass in middle, right? Of AB has mass 40 kilogram. So we can sort of draw a diagram in here. We can draw a draft one. There's a draft for 40G in here. We know it's right in the middle, 10 meters. So that's 5, that's 5. We can do a proper one later, next time, after this. Rest with the end on a rough horizontal ground. So the ground is rough, means there's friction, right? The rod rests against a smooth pack C, where AC is 8 meters. The rod is in limiting equilibrium at an angle 15 degrees to the horizontal. Limiting equilibrium means the whole thing is equilibrium. Equilibrium means up equals down, left equals right, moments at a point. Find the magnitude of the reaction at C. So let's draw in the forces. Now, think about chapter 4. Okay, so think of chapter 4. You've got some supports in here. Do you remember what are the forces on these support A and support B? Reaction A, reaction B, right? Now, they are pointing upwards because they are perpendicular to the rod. So for C, imagine C on this question is a support. So the reaction will be perpendicular to it. So I'm going to draw you a new diagram, okay? A diagram which is more forces on there. Right, so we have in here. So we have point C, which we have reaction C. We know that's a right angle in there. We know that's 15 degrees. We know that's mg right down there. And then we also know that's 5 meters. And that's also 5 meters. We're told AC is 8, so that must be 3 meters. That's point A and point B. Right, what else on A then? Well, think about this. You can try stand up if you're listening to video. You can stand up and then find a wall, okay, you can lean on. So I'll try to draw you a picture you can try to feel. So that's a wall, okay, that's you. You can try to lean against it. Super long feet. Anyway, you can try to lean against it. Now you can feel, okay, how would you feel the support on the ground given to you? Now imagine you're leaning against the wall. First of all, the fact that you're not sliding down, if okay, the floor is very, very slippery, then you'll be like this in no time, right? You'll be sliding down along the wall. So the fact that you're sliding down, that means there's friction here, wasn't it? And the ground is providing enough support so you're not falling into the concrete into downstairs. So that means there's also reaction provided, support provided from the ground. So we're going to put this on A. So on A, we have reaction on A, and also now because if there's no friction, the rod will be sliding that way, wouldn't it? If there's no friction, therefore the friction will be against it in here. Now I'm going to put an F, a small a, because that friction is on A, not on any other points. It's on A, so friction of A. So first step, you're going to make upward force equal downward force. Step number 1. I'm going to write down the steps for you. So step number 1. By the way, there's a complete diagram. We've got on this side, there's a complete diagram. Not the one on the right, obviously. That's also complete in my own terms. Step 1, okay, so we're going to make upward force equal downward force, and then left equals right. So let's have a go, shall we? Now, if it's up equals down, what you realize is RC is not up or down or left or right, it's diagonal. So what we have to do is, we can't do the first step yet because RC is not vertical nor horizontal. So here, put your little note. So put your little note. We have to resolve RC first because it is diagonal. So we need to resolve RC. So how to resolve RC? So I'm going to draw a right triangle like this. So upwards is Y, leftward is X. What about the angle? Now, if you think about parallel angles. This thing is really in the way. How can I get rid of this bar on a zoom? I can't. It's really annoying. So if you might be able to see there's a bar on the top from zoom, which is really annoying. Right. So if you think about parallel lines, then you will notice this angle here is 15 degrees because a set angle. So therefore, the angle that we need in here is 75 degrees. So we can draw the triangle out. So I'm going to draw the RC triangle like this. 75 degrees. Got x to the left and y upwards. So x equal RC cos 75. Y equal RC sin 75. If you know me well enough, you know I wouldn't put in a calculator because that number is ugly. I mean, I'm not saying we have to judge a number by its appearance, and neither should we judge by a person by it. But you know, no one like decimals. You know, especially non-ending decimal. So once we've done that, then we can start to achieve what we want to achieve. Upwards equals downwards, left equals right. Now, if you scan through the whole diagram, what are the upward forces pointing upwards? The upward forces from left to right, you've got RA, you've got MG, and you've got the Y component for RC. So we're going to do that. So upwards equal downwards. So that's the first thing we'll do, upwards equal downwards, okay? So upward force is RA plus what else upwards? The Y version, the Y component of RC is also pointing upwards. So we will use the RC sin 75. So plus RC sin 75 equal downward force, the mg. Oh, we're given the mass. Yes, we're given the mass 40. So it'll be 40 G. Actually, I'm going to change it to 40 G. And I don't like G. So 40 times 9.8 is 392. Going to put that in the calculator. So RA plus RC sin 75 equals 392. That's the first equation. Now, this question could easily worth 10 marks, by the way. So if you are thinking where are we leading, it looks like we're not leading nowhere. You're right, because this question is 10 marks. So you could imagine there'll be lots of steps to do. Step 2, and not step 2, part of step 1, left equals right. So we're going to do leftward force equals rightward force. Force. So again, scan the whole diagram. What force is pointing left? Can you find it? And what force is pointing to the right? Can you find it? Do I speak like Dora the Explorer? Something quite obvious. So pointing left is the x component of RC, which is RC cos 75. Pointing to the right is fraction of A. So we'll do that. Okay. So pointing left is x version of RC, which is RC cos 75. Do not copy the wrong thing, which I usually do. RC cos 75. On the right side, we've got fraction of A. What's the formula for fraction? Mu R. So equals to mu R. Now, the reason I put FA in there is because in a harder question, there could be friction on 2 places, 2 points. So then you have to say fraction of A and fraction of another point. So fraction of A, when you use the formula, then it becomes the R of A as well. So this in here. So the fraction of A equals mu and reaction of A. So therefore the A follows in the reaction. Because you've got reaction of C as well. So you'll be thinking which reaction we're using. But because friction is on A, therefore reaction is on A as well. So RC cos 75. Do we know mu? We don't. It's actually part B. Okay, so next, what can we do in here? Well, it looks like we can't do anything. You're right, because then we have to perform our second step. Let's look at notes again. We've done a step 1. Step 2, take moments at a point. Favorite bits. Take moments at a point. Which point will you take moments at? I'll give you time to think about which point will you take moments, A, B, or C. The answer will be A, because you've got 2 forces on A. If you take moments on a point, there's forces on that. The forces generated will have, the moment generated by those forces will be 0. So in a hindsight, we can, in a nutshell, we can ignore the forces when we calculate the moment at that point. So we take moments at A because then we can ignore RA and FA. So once we ignore RA and FA, how many forces do we have to calculate moment? We've got 2, RC and 40G to calculate. Then you'll be thinking, sir, what about Y and X? Do we not have to calculate it? Yes, you can, but that will be long. Reason being is Y and X are, they came from RC. So when you work up moments based on Y and X, when you do the magnitude, that kind of thing, altogether, it'll give you the RC anyway. So it doesn't matter which way if you do. You don't want to do X and Y because you're doing 2 when you can only do 1. When you only have to do 1 RC. So I'll say again, to work up moments at A, you have to calculate 40G and RC, just RC. Okay, not the X and Y, because when you calculate moments, if it's vertical or horizontal, it does not matter. So let's calculate moments at A, and then we'll calculate moments of RC and 40G. So step 2, take moments at A. Step 2, take moments. Oh, I have to write in black because that's what you should write in the exam as well. So take moments at A. So we've got 40G to calculate. Remember the formula for moment. Moment equals force times that perpendicular distance. Question for you. Where is the perpendicular distance from A to 40G? Where is the perpendicular distance from A to 40G? It's right here. That's the distance. Oops. Does it not look like a girl trying to put in the lipsticks and they can't put in the right place? That's what it looked like. Oops. Yeah, anyway. Right, anyway, so that's the perpendicular distance. So it'll be 5 cos 15. So this is all coming from chapter 4. So moment equals force times distance. I'll draw a little distance for you. So this is 5 meters, which is 40G. That's the distance. 15 degrees. So moment equals 40G, the force times the distance, which is 5 cos 15. You want to put in a calculator? You can, or you don't have to. Let's do it. Why not? 40 times 9.8 times 5 cos 15. Make sure you calculate in degrees, not radians. You get 1893.21462. So I'm going to store this value in the calculator. If you don't know how to store it, make sure you ask the teacher. You should know by now. Times 5 cos 15. That's 1893. So I'm going to store it in A. That's A. Next, so I've done 40G. What's the other one? RC. So calculate moments on RC. Now, if RC, what is the perpendicular distance from RC to A? So using a pencil, hold your pencil there. Try to draw a perpendicular line from A to RC. Is actually this one here, which is 8 meters. So RC moments equals RC times 8, which is 8 RC. Oh, I do forget to include direction. That will be clockwise. This will be anti-clockwise. Step 3, the moments equal each other. So anti-clockwise moments equals clockwise moments. Anti-clockwise is 8 RC. Clockwise moments is 1893. So divide that by 8. 1893 divided by 8 is 237 Newton. Now that's not a full answer. The actual answer I've got in calculator is 263.6518, etc. If you're doing with a calculator with me, make sure you have a go as well. I'm going to store this in C because I can remember RC. So I'm going to store it in C. So next part, I need to work out the coefficient of friction. Now, I've said many times in mechanics, you don't have to do it question by question. You can just work out like what I did, a big calculation, and then you will find all the things in this type of question. So follow my method, and I can guarantee you will find everything you need. You will answer most of the question, unless it's a 1 mark or 2 mark question asking you, what do we mean by uniform rod? What assumption you've made? That kind of stuff. You have to read the question. In terms of calculation, that's everything you have to do. Okay, so follow my method. Step 1, do not care what the question asks. If you know this question is from this chapter, I just follow my method. Up equals down, left equals right. When the force is not vertical, horizontal, just resolve it. and then up equals down, left equals right. Take moments at a point. Clockwise moments equals anti-clockwise moments. You found one of them. Next one, to find the mu, we have used these will become handy. Right? So we know, so step by step, in order to find mu, I need to find RA. So I'm going to sub into this equation. So RA plus RC equals sine 75 to 392. So I can say in here, sub into RA plus RC sine 75 equals to, what's that again? RA plus RC sine 75 equals 392. So we're sub into that one. So RA plus 237 sine 75 equals 392. So RA equals 392 minus 237 sine 75. The 237 wasn't 237, it was a calculator value, full value in the calculator. So I do 392 minus, I saw it in C, so minus C times sine 75, close the bracket. I got RA equals to 163.411, etc. I'm going to store this in D. Then I can do the last bit, so which is to sub into the RC cos 75 equals mu RA. So sub into RC cos 75 equals mu RA. So if I rearrange it to make mu the subject, RC cos 75 over RA equals mu. So mu now equals to, in the calculator, what I would type is, my RC is C value. So I'll put in the fraction C cos 75 divided by the answer of D, because store RA in D. You should get 0.375 in 3SL. You know, this is maybe correct is because mu is between 0 to 1. So that's the first scenario. The second and third scenario, the calculation will be very similar, but it's just the initial forces that are put on diagram is different. Quick recap again, what have we done? When we know this about a rod, then we know we're not doing all the previous shenanigans in chapter 7.6 about inclined plane. We're not using F equals ma. Okay, what we essentially what we do here is we have to make up equals down, left equals right. Before we do that, we need to put in the forces. When there's support in there, the support force, reaction force will be perpendicular to the rod. And then on the ground, you've got reaction acting because the ground is providing it. Therefore, the reaction will be perpendicular to the ground, which is pointing upwards, RA. The rod is not sliding down. There will be friction. Harder question, there might be a friction in here as well. How do we know there's no friction? Because it's smooth peg. So if this peg is rough, then hypothetically, there will be RC pointing to the right in here along this line. Why? Because without this RC, without this friction, the rod will be sliding down as well. Anyway, I think you might encounter this in the homework. So next, upwards go downwards. RC is not upwards nor horizontal, so we resolve it, and up goes down, take moments at a point, and then clockwise moments equal anti-clockwise moments. From there, the calculation, the method is finished. The rest of them is just the aftermath, pun intended, aftermath. Solve the simultaneous equation, and then you found everything you need. Okay.